Hi everyone, in this lecture we will learn how you can use Lambda functions as decorators in Python. So I hope that you know the concept of decorators. We have discussed it in the previous lectures, but today we will implement it using Lambda functions. So for example, let's define here a simple regular function, and this function is going to find the sum of two numbers. It will take a and b as parameters, and it will simply return the sum of a and b, and it's a very straightforward function. And if I call it here print sum and then 2 5, you will see that it will print 6 on the terminal, and we got 6. Now I want that instead of printing the sum of the numbers, this function should print the sum of square of the numbers. So one method is to modify the internal structure of this function, and the other method is to use a decorators. And we will use decorators, and instead of using a regular function decorators, we will use a lambda function decorator. So first of all, you need to put here this at the red sign in order to tell the Python interpreter that now you are going to decorate this function. And then you need to define here your lambda keyword. So just write here lambda lambda. So generally we use at the rate and then the function name, but since the lambda function returns the function object, so we don't explicitly need to define the lambda function in a separate line and then passing the reference of that lambda function in front of this at the rate sign. So you can directly define your lambda function in front of this at the rate sign as well. So lambda function, and first of all, if you remember, if I open this decorator side by side, so here as you can see, this is our decorator function. And first of all, outer function or the enclosing function takes function as a parameter. So this lambda, you can consider this lambda as an outer function, and the parameter of this lambda function will be func or func, because this lambda function is going to accept a function, and then we need to put a colon. And now in the equation or in the body of the lambda, we need to define an other function, because here as you can see, in our enclosing function we have an inner or a nested function. So just write here another lambda keyword. Now this function takes same number of parameters which our outer function takes. So here as you can see, this string underscore returner takes only one parameter. That's why this or def operator function is also taking only one parameter. Keeping this in mind, this lambda function is going to take two parameters because our this function which we want to decorate takes two parameters a and b. So let's write here x and y. So you can use different names or you can use the same names a and b as well. So lambda x and y. And now in the body of this nested function, I need to implement my main logic, and in this case I'll simply return this sum function which I'll accept right here. So just write here func, and in the parameters I have told you that instead of printing the sum of the two numbers, I'll print the sum of squares of these two numbers. So these are my two numbers, and I just need to find the square, and I'll pass them right here. So just write here x double asterisk signs, which tells the Python that now you need to put the upcoming number in the power of this previous number. So x raised to power 2 and then y raised to the power 2. So this is our logic. Let me close it. First of all, I'm defining a main function. You can consider this lambda as the outer function, and this function accept a function as an argument, and then in the body of this function or this anonymous function we have an other anonymous function, and this anonymous function takes two arguments x and y, because our this sum function takes two parameters x a and b. and then in the body of this inner or nested anonymous function, we are simply returning the function, but we are modifying the parameters of this function. And now if I run this, and we got 20, and the reason is that if you put 2 in the power of 2, you will get 4, and if you put 2 in power of 4, you will get 16, and if you add 16 and 4, you will get 20. Now let's modify these values. Let's type here 5, and just type here maybe 3. Let's run it, and now we got 34. And now let's implement another logic. Instead of printing the sum of squares of the numbers, I want to print the square of the final answer. So for this purpose, I just need to multiply my final answers. So I'll just put an other asterisk sign, and then I'll call the same function. So just copy it and paste it right here. Now I'm finding the squares of the numbers and then finding its sum, and I'm multiplying the answer which these two functions will return. And now if I run it, we got 1156. And if I open my calculator, and if I multiply 34 with 34, you will get 1156. So this is how you can use lambda functions as decorators to modify the existing functions. And I hope that you have understood this logic, and now your task is to implement the same logic using regular functions. So I hope that you will enjoy your homework, and I'll see you in the next lecture. Bye bye.